In this video, I'm going to be walking through how you can test for the mean of a Poisson distribution. To carry out a hypothesis test for the mean of a Poisson distribution, you form two hypotheses, H0, where lambda equals m, which is known as the null hypothesis, and this is the value that you assume to be true, or H1, which is the alternative hypothesis, and this tells you about the value if the mean of the null hypothesis is wrong. Remember, the Poisson distribution has a mean, lambda, and a variance, lambda, so the mean is equal to the variance. And now we're going to solve a problem. Bacteria are randomly distributed in the water of a lake at a rate of 7 per litre. The new factory opens next to the lake, and the local residents feel that the factory is polluting the lake. To test this claim, a random sample of half a litre, be careful because this says per litre and this is half a litre, of water from the lake is examined and found to contain 8 bacteria. Test at 5% level of significance whether there is evidence to support the claim of the local residents. Okay, so firstly what we want to do is model it in a Poisson distribution. So the rate for 7 bacteria per litre is 7. So the Poisson is 7. But you want to find the rate of half a litre. And assuming this is constant, which is something we assume in a Poisson distribution, we can say that the rate of half a litre is 3.5. And so our null hypothesis is where lambda equals 3.5. And our alternative hypothesis is where lambda is greater than 3.5. And this is because the 8 bacteria is greater than 7 bacteria and greater than 3.5 as well. So we want to test at a 5% significance. And so we want to find the probability of when x is greater than or equal to 8. And this can be written as 1 subtract the probability of s less than or equal to 7. And you can use your calculator with this Poisson distribution to find that this is 0.97326, which gives you 0.0267, and this means the significance is 2.67%. And thinking about the bell curve, we want to find out whether it's below 5%, and it is. And so there is enough evidence to support the claim of the residents, and therefore we reject H0.